Okay. Okay, boys and girls, we pick up here. My caution to you this day is that I know it's Monday and it's tough to kind of get things going right away. This first part, the second part is easy today. The first part seems easy, but without a doubt, this is probably the number one area that people make mistakes on the test. Okay, so we we've got to understand this. I get questions about this all the time. We need to state the domain without looking at the graph. You guys are very good at stating domain by looking at the graph, but without looking at the graph, who knows? You can plug it in your graphing calculator and identify, but we want to be able to look at it and identify it algebraically. So what you have to understand is the nature of every type of function and what you can do and what you can't do. For example, if I have y equals x squared, can you tell me, is there a certain number out there that you can't square? Is there a real number out there that you can't square? No. I mean, you square negative 40, right? You get 1600. You can square 0, you get 0. You square 1, you get 1. Square negative 2, you get 4. Square 100, you get 10,000, right? So the domain for y equals x squared is all real numbers because you can plug in anything. But look at this example. Square root of 9 minus x. Is there a number that you can't take, a real number that you can't take the square root of? Any negative, correct? So let's just try plugging something in. 9 minus 1. Can you take the square root of 8? 9 minus 0. Can you take the square root of 9? 9 minus negative 16. Positive 25. You can take square root. Yeah. Now let's plug in positive 25. 9 minus positive 25 is negative 16. Can you take square root of negative 16? So we found one that doesn't work. 25 doesn't work. So here's how we do it. We say you can't take the square roots of negatives. So we force 9 minus x to be not negative. What does it mean to be not negative? Very close. You can be positive or 0. So greater than or equal to 0. So as long as 9 minus x is greater than or equal to 0, we're good to go. That means that whatever is underneath here is not negative. I subtract the 9, get negative x is greater than or equal to negative 9. Divide by negative 1, x is less than or equal to positive 9. As you write the domain, you may state x is less than or equal to 9, or you could write from negative infinity to positive 9 with a bracket. Any questions how I did that? That's the domain. You try plugging in numbers here. You try plugging in 10. 10's not included, is it? 9 minus 10? Negative 1. Can't take square root. So that should make sense. Okay, look at the second one. Sometimes when we divide things, we come up with issues. What are the type of numbers that, what's the number you can't divide by? Why? Do you know why it's undefined? I mean, somebody just told me that one time. You ever understand why it's undefined? If I take 0 and divide it by 5, what that means is how many 5s can I add up before I get to 0? Like 5 plus 5 plus 5, plus 5. Okay, if I add them up, how many zeros can I start adding before I'm at 0? None. Like, give me none, and I'll be okay, right? But look at the other way. If you take 5 and divide it by 0, what that's saying is, okay, what if I add up 2 zeros? Am I good? How about 3, 4, 5? Well, will I ever get there? Like, if I add up an infinite number of zeros, will that finally reach 5? No, it won't even reach 1 over infinity. I mean, it doesn't reach anything, okay? So it's undefined. Well, hi, buddy. Welcome. Okay, so we go back and we look at it. What is a number that you would plug in for x that would give you 0 in the denominator? 2. So x cannot equal 2. You can write that for the domain, or you can write from negative infinity to 2, union with 2 to infinity. Either one is fine. What's different about the next example? One of these is not like the other. There's two, right? So you have to factor the bottom. X minus 3, x plus 2. So what are the two numbers that x cannot be? Yeah, 3 and negative 2. So you could write that as negative infinity to negative 2, union with negative 2 to 3, union with 3 to infinity. Or you could write x not equal to 3 or negative 2. I think we still have people in class who haven't answered the questions here. So we gotta take a chance. Just throw it out there, right? Might be wrong. That's okay. We're all wrong every once in a while. All right, next one. What's different about the next one? It's a cubed root. Now, here's where you really got to put your thinking cap on. Can you take the cubed root of a positive? Cubed root of 8 is cubed root of 64. Cubed root of 125. 5. What's cubed root of 0? What's a cubed root of negative 1? Negative 1. Because negative 1 times negative 1 is 1 times negative 1 is negative 1. What's the cubed root of negative 27? Negative 3. So can you take the cubed root of positives? Can you take it of 0? Can you take the cubed root of negatives? Yeah, you can take the cubed root of anything. So therefore, the domain is all real numbers, or from negative infinity to positive infinity. Even roots have to be positive. Odd roots, you can have anything. Does that make sense? Okay, these two examples will start to trick you a little bit. Okay, let's make sure we understand these. The square root of 9 minus x squared. I can't take the square root of negative. So therefore, I take 9 minus x squared, and I set it greater than or equal to 0. Oh, now I have an inequality that's quadratic. So we actually looked at these in chapter 1.7. And you learned how to solve these. You remember how to solve these. You got two options. You can either look at the graph or make a table. It's your choice. I'm going to graph it because I know what it looks like. It factors to 3 minus x and 3 plus x. So this is asking, how did I know it went down? There's a negative in front of the x squared. All right. Now, the question is, where is 9 minus x squared? Where is it greater than or equal to 0? What does it mean to be greater than or equal to 0 on the graph? Above the x-axis. So it's above in these positions. It's below in these positions. So therefore, my solution will be from negative 3 to positive 3, or in interval notation, look like this. Okay with that? So realize if you have an inequality that's not linear, you got to maybe think about it a little bit harder. Okay, last one. Anybody see the trick here? What's unique about this? You have a square root and a fraction. So we got to look a little bit deeper here. First, I'm going to start with the top. Domain for the square root of x. I have to take x and set it because I have to have the square root of numbers that are not negative. Now look at the bottom. What can x not be when I factor that? Now there's a problem there, folks, because up here it says, well, my domain should be x values that are greater than or equal to 1, or greater than or equal to 0. On the bottom here, I can't include 0 or 1. Both of these numbers are included in that, aren't they? So I have to exclude it from the overall set. If you were to look at the graph of the domain, we would say, well, we're starting at 0, and we would have a closed circle, and we'd go up and over this way. But the fact is we have to exclude this number 0, and we have to exclude this number 1. Okay? So you would say we're going to start at 0, but we're not going to include it, and we're going to go to 1, not included. And then we'll pick up with 1 not included over to positive infinity. So probably open circles would have been the better choice, but I want you to understand we got to exclude it. They can't be part of the solution set for the domain. Is that clear? You have to make sure that you practice this assignment soon. Do not put this off. You will ask questions about it, and you won't get the answers right on the test. Do we come back to this in future? Yes, all the time. This is part of college algebra and trig for the rest of the semester, and it's part of calculus next year. Okay, we move on. We finish this part, and then I'll hand out a worksheet to you and an assignment, and we'll go from there. So we're going to spend 2 days on graphs of functions, and we're going to start by looking at a visual as opposed to plugging in values. So it says, given the graph of the function f, identify the following. So this is my function f, and I want to know f of -2, f of -1, so on and so forth. Last week, I gave you those values, and you plugged them in. In fact, we went so far as to plug in a and a plus h, and we did that whole formula. And you guys got good practice with that on Friday, right? You feel confident with that? Good. So now we're going to look at a visual description of what this should be. And so if I want to, there you go. Okay. So it says, given this graph, f of -2, I will plug in -2, and I will look for the height of the function for an x value of -2. What's the height of the function right there? 0. Now I'll plug in -1. -1 is interesting because it looks like the graph has 2 spots. It has an open circle spot and a closed circle spot. Which one do I choose, the open or the closed circle? I choose the closed circle. And so it has a height of what at that spot? 3. F of 0. F of 0 is somewhat interesting as well. You notice if you plug in 0, you have an open circle there, and then this graph seems to just kind of go straight up. It follows right along the y-axis, but never crosses it. So is there a value at 0? No. So we would say it's undefined. F of 1. Again, I go to the closed circle and not the open one, so it has a height of 2. And then F of 2, looks like I'm going to have to approximate that. 3.4? You also want to be able to look graphically at a function and be able to determine the domain and range. So we looked at algebraic examples. Now we're going to look at it graphically. Determine the domain by looking at the graph. Ms. Nelson and I have talked for a number of years the best way to teach this, and we both feel that it is best to drag the vertical line across. When you're looking at x values, x equals is a vertical line. So therefore, I drag a vertical line across, and I determine the domain from that. Will the graph cross this vertical line at some point? Yes, it will. So all the way back here at an x value of, say, -5 or negative infinity, I do have values. Does the graph have values here? Here, 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 here? No. 0, it does not. How about here? Here, here? Yeah, it's gonna cross the graph from values of negative infinity all the way to 0, and then from 0 all the way to positive infinity. So the domain you could state is x not equal to 0, or you could write from negative infinity to 0, union with 0 to infinity. Then we want to state the range. For the range, instead of dragging a vertical line, I drag a horizontal line, and I start way down here. What is the value way down here that I'm considering? Negative infinity. So, will the graph cross down here at some point? Yeah, not due to this, but due to this, correct? So this will continue to go down. It will go all the way down to negative infinity at some point. Does it cross here? Yeah, due to this spot right here, it crosses. So I know I have an open circle, but it does cross right there. And this line will also cross about there. Yeah, from negative infinity to positive infinity. There are no values excluded here, is it? Or ranges from negative infinity to positive infinity. Now, a different kind of question. This is a great question. This is a question you would see on an ACT or some other time. What are the domain values that satisfy f of x is equal to 2? So f of x equals 2 means where does the function have an output of 2? So I'm going to put this horizontal line of y equals 2 right there. And what we want to find is what x value would you plug in to get an output of 2? So we'll estimate here, but it looks like the first spot where this graph has a value of 2 would be right there, correct? So what x value would give you an output of 2 that's approximately right there? Negative 1.3? Sure, sounds good. Looks like I have another spot right there. What would you estimate that to be? 8.2? I have another one right here. Estimate that. 0.5. Don't forget about the spot where you have a closed circle there. What's that? Next one. Sure, 1.3. And it looks like I even have another one over here. 3. So it's okay to have many x values that have the same output. We could have 15 people on a basketball team and have them all score 4 points during a game. Okay? It's okay for all the players to score the exact same number of points. What's not okay is for player number 3 to score 4 points, 8 points, 20 points, and 2 points in a game. That can't happen. Okay. All right. So what I want you to do is I want you to write down your assignment, which I erased. That's the first part of your assignment, which we practiced right away. Now I'm going to hand out the worksheet that I need you to work on as well. So a number of people were able to finish this during third hour. If you guys work hard, you can. Okay, please look at the worksheet in front of you. I'll do 3 quick examples for you. The first one's pretty straightforward. Again, you could drag that horizontal line and that vertical line across. And if you do so, for number 1, especially when you see arrows on the end like this, the domain is from negative infinity to positive infinity. And the range in this situation is negative infinity to positive infinity again. Every single time you pick an x value, say you pick an x value way back here, you will find a corresponding y value. Every time you pick a y value, you will find a corresponding x value that goes with it. So there's the domain and the range are from negative infinity to positive infinity. Okay? But number 3 is different. Anybody look at it and see what the domain is? Again, negative infinity to positive infinity, all real numbers. The range, on the other hand, what is the very first value that you get out? -5. Is that -5 included? Yes, the graph goes all the way down to -5. And then from there, it goes up to infinity. Look at number 5. There we'll have to restrict both the domain and the range. Tell me something interesting about the domain. There's only 2 numbers. What are the 2 numbers? So if you wrote this, -4, 3, what that would mean is that you're including every number between -4 and 3. And that's not accurate, is it? So therefore, in order to designate that it's only the numbers -4 and 3, yes, the official term is squiggly lines. And so we use -4 and +3, squiggly, squiggly. There you go. We call that roster notation. It's the way that you list a roster, just as you would, your basketball team. You list off the numbers that are available to play in the game. And then the range, the outputs, where does it start? -5, and it's included, and it goes up to -2. And then there's a slight break. So we have to union the next part, which is 0 to 4. So if this sheet looks familiar, it's because Miss Nelson stole it from me, and she used it last year for you guys. The answer key is right there. And I did want to just let